Okay, here's an interesting question with some probability. We've been looking at equally likely outcomes. So if Emma says her chance of winning the lottery is a half, because there's two outcomes, you either win or you lose. What do you think? Why haven't I won it yet? I've played it more than twice. Well, this is wrong. She has kind of taken this likely outcomes and oversimplified it. The probability of actually winning the lottery is about 1 in 14 million, just under 1 in 14 million, and that's why people don't win it often, and that's why you win millions for winning it. And that is because I think there's 50 numbers to pick from, and you have to get 6 of them bang on. You'll see in later years of school when you do probability again of why exactly this happens, but I thought this is a really interesting question. Maybe you want to research into the probability of the lottery, but it's not a half, and don't play the lottery. If you played for, I think, 40 lifetimes every week, you'd only have a chance of a half of winning, but that's something for another day. So I'll give you a preview of what we're going to be looking at. We're going to be looking at some worded probability again, so saying stuff is impossible, unlikely, even chance of happening, certain, and then we're going to be looking at designing our own spinners on some criteria. So this is my spinner, and I'm going to kind of go through 2 of these and then set you off. So the probability of landing on a 6 is 1 over 8. And how many boxes have I got in this spinner? 1, 2, 3, 4, 5, 6, 7, 8. So that means 1 out of 8 of these is a 6. So just 1 box is a 6. The chance of landing on a 3 is 50%. 50% is half. So half of these must be a 3. So that would be 4 of them. We can see I've made a half of these 3. And it's more likely to land on 4 than 2. So I need more 4s than 2s, basically. And I think there's quite a few options with this. I could have 2 4s and 1 2. I could have 4 4s. I don't need to have a 2 on there, because it's more likely to land on a 4 than a 2. Well, if there's no 2, then that's definitely the chance. Definitely there. So I'm going to put 4 4 2. Let's just double check of this, right? 1 out of 8. Yep, 1 out of 8 of these is a 6. 50%. Yep, that's half of them 4. And there's more 4s than 2, so there's more chance of me getting a 4. Spot on. Let's have a look at a different example here. So the probability of landing on a 2 is a quarter. So 25% of the time. Let's check how many boxes I've got again. I think there's 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So instead of 1 out of 4, I want to make this out of 8. So I could say that that's 2 out of 8. So I want 2 of these to be a 2. That'll give me a probability of a quarter. Chance of landing on a 4 is 25%. So again, I want a quarter of these filled in with a 4. So that is going to be 2 4s. The chance of landing on a 1 is 0. Remember, if we said something has a probability of 0, that means it's impossible. So if something has a 0 chance of landing on it, there must be no 1s at all in this spinner. And it's most likely to land on a 5, so I need more 5s than any other number on this spinner. So I need more than 2 5s, because if I had 2 5s, it would be equally likely to land on a 5, a 2, or a 4. So I need at least 3 5s. And then I think whatever you put in this last box, as long as it's not a 1, a 2, or a 4, you're kind of okay. So shall I test out that theory? I'm going to put a 3. Yeah, perfect. I could have put a 6, I could have put any number, as long as it wasn't a 1, a 2, or a 4, because that would have affected this first 3 criteria. And go on, let's do one more example. This one will be a little bit harder, I think. Probability of landing on a 3 is 3 out of 8. So I need 3 of these to be a 3, because 3 out of 8, 3 there, out of 8 total. Has an equal chance of landing on a 1 or a 2. So I need the same amount of 1s and 2s. I don't know what number that'll be. I'm going to leave that for a moment. It is certain to land on a number less than 5. So that means every single number on here has to be less than 5. So it can't be 5, it can't be 6, it can't be 7, etc. So that's good to know. And it's most likely to land on a 3. So I need more 3s than anything else. So I can't have 3 1s or 3 2s. So how about I do 2 1s, 2 2s, and then what do you think I can put here? So it's equally likely to land on a 1 or a 2, because I've got 2 of them each. I've got 3 out of 8 for my 3s. It's most likely to land on a 3, so I can't put another 1 or a 2, because that would mess up B, and it would mess up D. Can't put a 3, because that would mess up A. So I could put 0. I could also put a 4, because that's less than 5. They're both less than 5, so I'm going to put 4 there. Perfect. So on your task, there's actually only one possible answer to all of these. So unlike mine, I had a few options on the last one, just to help you out by knowing if you're exactly correct or not, using the numbers 1 to 6, so have to be between 1 and 6, no zeros. Complete these spinners so they match the probability statements that they describe them. And I will show you that there's actually, it says on the right at the bottom of your screen here, there is only one solution for each spinner. So if you don't get the exact solution that I post for you to check your work, then have a think again. But you can put me in a different order. I mean, it doesn't matter if you put a 3 there or a 3 there, as long as you've got the right amount of them numbers. Yep. Okay. So thank you for listening. It was nice and short.